Hello and welcome. I'm Dr. Pauline Fu. In this video, I will present hypothesis test for two independent samples. Learning objectives. Test hypothesis regarding the difference of two independent sample population means. Construct and interpret confidence intervals regarding the difference of two independent population means. Sampling distribution of the difference of two means. This is for independent samples, okay? And it is under condition we do not know standard deviation. So we also refer this test as a Welch's T test. So this is the scenario. Suppose that a simple random sample of size N1 is taken from a population with unknown mean mu1 and unknown standard deviation sigma 1. In addition, a simple random sample of size N2 is taken from a population with unknown mu2 and unknown standard deviation sigma 2. If the two populations are normally distributed, or if the sample size are large, means greater than 30, then we have this rule. Okay, the standard deviation, we call this one here the formula for T. This is the standardized T. It is a sample 1 mean minus sample 2 mean minus the difference of two population means over square root of sample 1 variance over sample 1 size plus sample 2 variance over sample 2 size. And this one is approximately follow T distribution with a degree of freedom being the smaller of N2 minus 1 and N1 minus 1. The smaller one is the degree of freedom. Okay. So this is a sampling distribution of the difference of two means follow student distribution. When we test the difference between two independent population means, we always assume that the samples are obtained using simple random sampling. Samples are independent. The populations are normally distributed, or the population has large sample. The sample has large sample. And for each sample, the sample size is less than 5% of the population size. Step 1, you need to state the null and alternative hypothesis. There are three situations: two-tailed test. So null hypothesis is mu1 equal to mu2. Alternative hypothesis, mu1 not equal to mu2. Left tail test, you have alternative is less, okay, and mu1 still is H0 is mu1 equal to mu2. Right tail test, H1 has greater sign, okay, and null hypothesis is equal. Okay. In step 3, we usually calculate the test statistic, and this is the formula for test statistic. Take the difference of sample means minus the difference of population mean, and this one usually is 0, usually, not always. Okay, and then our sample 1 variance over N1 plus sample 2 variance over N2, and the degree of freedom is the smaller of N1 minus 1, N2 minus 1. Okay, take a smaller value, that is the degree of freedom. When you use classical approach, you need to find the critical value. This method is exactly the same as we did in the previous lectures. Two-tailed test, 2 critical values, 2 rejection regions. Okay, and if you have left-tailed test, you have a critical value here, rejection region on the left-hand side, left tail. If this is right tail test, rejection region is right tail. Okay. If you have 2-tailed test, and after you identify critical value, then label your test statistic. If your test statistic is here, you reject H0. If your test statistic is here, you do not reject H0. If your test statistic is here, reject H0. If your test statistic is here, do not reject H0. Okay, so this is what it is said in this table. Okay, when do you reject H0? When test statistic is in the rejection region. And when you have left tail, if test statistic in the rejection region, reject H0. And when you have right tail test, when you have test statistic is in the rejection region, reject null hypothesis. So we introduced classical approach. Next, p-value approach. Remember, p-value is the area corresponding to test statistic. Once you have this test statistic, okay, you label the test statistic here, for example, t0. And what is the p-value? P-value is the area corresponding to t0. If it is two-tailed, you have these 2 areas are together is p-value. And if it is a left-tailed test, and you have your test statistic negative t0 here, the p-value is the left tail here. Okay, and if you have right tail test, and this is test statistic t0, the p-value is just the right tail area. Okay, so those p-value refer to here, left tail, p-value equal to here, and in this, you add those 2 tails, that is the p-value. So I already illustrate this. Okay, left tail is the p-value area, right tail area is the p-value. And the procedure is robust, means minor departures from normality will not adversely affect the results. However, if data have outliers, you should not use this procedure. Now, let's take a look at an example. Researchers wanted to know whether the state quotas had a weight that is more than, see the keyword more than, traditional quotas. He randomly selected 18 state quotas and 16 traditional quotas, weighted each of them, and obtained the following data. Okay. So obviously, these 2 samples are independent samples because randomly selected from one sample does not affect your selection from another sample. They are two independent samples. Okay. So you want to test the claim that the state quarters have a mean weight that is more means H1 has a greater sign. Okay. You want to test H1 greater, so mu1 greater mu2. Remember H1 always is equal, mu1 equal to mu2. Alpha is 0.05. So before we do hypothesis, let's check the condition. Okay. When you construct a box plot for traditional quarters and for state quarters, there is no outliers. Okay. And also, we assume the two populations are normally distributed. So, 3 steps. 1, no hypothesis, mu1 equal to mu2. Alternative hypothesis, mu1 greater mu2. Step 2, specify level of significance alpha. Step 3, calculate test statistic. Remember test statistic is X1 mean, sample 1 mean, minus sample 2 mean. Then minus population 1 mean, minus population 2 mean. And divide square root of sample 1 variance over sample 1 size, sample 2 variance over sample 2 size. Okay. And because you are given the raw data, so this state is sample 1, traditional is sample 2. Of course, you can calculate the average of sample 1, standard deviation of sample 1. You can calculate the average of sample 2, standard deviation of sample 2. Okay, so we already calculated sample mean, sample 1 mean 5.70022, and sample 2 mean 5.6494. Mu1 minus mu2 is 0. Why? Because you assume mu1 equal to mu2. It is like in the court situation. A person is innocent until proven otherwise. Okay, so from mu1 equal to, you assume mu1 equal to mu2. Therefore, mu1 minus mu2 equal to 0. So on the top, you just have x1 bar minus x2 bar. Okay, and you do the calculation, you get a test statistic 2.53. And when you choose to use classical approach, you need to find the critical value. This is the right tail test. Why? Because H1 has greater sign. Why H1 has greater sign? Because the problem said it is more than, when you have more than, usually it is H1 has greater sign. So we need to find the critical value. Okay, and the degree of freedom, you have to choose a smaller one. So let's say N1 you have 18 minus 1, 17. N2 is 16 minus 1 equal to 15. So you use 15 as degree of freedom. Okay, and this is one-tailed test. You need alpha. You need degree of freedom to find the critical value. How? So you can go to the table here. I'm going to use Excel. Okay, so critical value for one tail T dot INV. Okay, and the probability is 0.95. Why? Because it is based on area to the left. Okay, degree of freedom is 15. and you get critical value 1.753. See here, 1.753. This is the formula I entered. Now, critical value 1.753, okay, and the test statistic we get from step 3, 2.53. So 2.53 is here. Obviously, test statistic is in the rejection region. So you reject H0. Where is H0? You reject H0. Therefore, you conclude the mean for state greater than the mean for traditional quarters. Okay, your final conclusion. So this is the critical value approach. We also call classical approach. Next, p-value approach. For p-value approach, you need to find the p-value. Remember what is p-value? P-value is the area corresponding to test statistic. Okay, there's construct renovation in the neighborhood. Sorry. The test statistic is 2.53. We get from step 3. So when you have 2.53, the question is, what is this area? Okay, what is this area? And we can use Excel to do it. Okay, use Excel to do it. Remember Excel, it is based on area to the left. So to do this area, detail right tail area, it is equal to 1 minus this big area here. And this big area is T dot dist. Okay, distribution, T distribution, x 2.53, degree of freedom 14, accumulative yes, 1 is yes, okay, and you get 0.012. That is your p-value. Okay, so this is the formula. Okay, and your p-value is 0.012, 0.012. This p-value. Obviously, this p-value is smaller than alpha, 0.05. So you conclude, reject H0. The same conclusion as we got from classical approach. There's a little note here. The degree of freedom used to determine the critical value. We use the smaller of n1 minus 1, n2 minus 1. Okay? If you want to get more accurate result, you can use this formula to calculate degree of freedom. So far, we did 2 approaches, classical approach and p-value approach to test the 2 population means. Next, we'll build or construct confidence interval for difference of 2 population means. Assume a random sample 1, N1 is taken from population. The population mean is mu1, we don't know. The population standard deviation sigma 1, we don't know. Now we have another sample. Sample size is N2, taken from another population, mu, with mean mu2. Standard deviation sigma 2. And we sometimes naturally assume those 2 populations are naturally distributed, or the 2 populations have large sample size. So the confidence interval is just the formula for lower bound and upper bound. So sample mean minus sample 2 mean, and t half alpha is the critical value times square root sample 1 standard deviation squared over n1 plus sample 2 standard deviation squared over n2. Okay, and t half alpha, this critical value is based on the smaller of n1, n1 minus 1, or n2 minus 1. So that is the formula for lower bound, upper bound. Next, let's take a look at an example. Construct a confidence interval for difference of two means. So the question asks you to construct 95% confidence interval about the difference between population mean weight of state quota versus the population mean weight of a traditional quota. Okay. So the data is based on this data here: state quota, traditional quota. Remember, those samples are independent samples. So based on this formula, we need to calculate x1 bar, and we need to calculate x2 bar, sample 2 mean. We need to calculate sample 1 standard deviation, sample 2 standard deviation, and we need to calculate the critical value t half alpha. N1, N2 is obviously is given. Okay, so we need those numbers in order to calculate lower bound and upper bound. Okay. So the result of x1 bar, x2 bar, okay, sample 1 standard deviation, sample 2 standard deviation. And you can find the critical value from table, or you can get this critical value from Excel. Okay, and how do you get from Excel? Remember, confidence interval always refer to two-tailed situation. So when you use Excel, there is a built-in formula. So you type in t.inv dot 2t means two-tail. Okay, and then 0.05 is the alpha. Degree of freedom is 15. Okay, and you get this critical value. So this is the formula. 2.131 is the critical value. And once you have the critical value, this is critical value, you can just plug in the numbers to get the lower bound and upper bound. Okay. So how do you interpret this lower bound, upper bound? The interpretation is we are 95% confident that the mean weight of state quotas is between 0.0086 and 0.0974 ounce, more than the mean weight of traditional quotas. Okay. Since the confidence interval does not contain 0, we conclude state quotas weight more than traditional quotas. See, this confidence interval does not contain 0. If it contains 0, what is your conclusion? You conclude those two means are the same. But here, this interval does not contain 0. So you conclude one mean is greater than another mean. Okay. The last slide said when population variance. So far, we assume we don't know population variance. Okay, if population variance are assumed to be equal, we use pooled t-test for difference for two independent samples. The pooled t-test is computed by finding a weighted average of sample variance and use this average in computation of test statistic. And if you use pooled variance, the degree of freedom, you use N1 plus N2 minus 2. Okay. The disadvantage of this test is that it requires we assume population variance are equal. Okay. In summary, what I did in this video, I did hypothesis test for two independent population means I used classical approach and p-value approach. I also constructed confidence interval estimate for the difference of two independent population means and interpret the confidence interval. That's all for this lecture. Thank you so much for your time. I'll see you next time.